Alright, so how's it going? So I'm in the midst of working on this LED grow light, so I plan on sharing that, so heads up for that. But today I want to talk about my capacitive discharge welder. I had some questions in the comments, so let's bring that up. Alright, so there it is in all its splendor. So we're going to talk about this for this video. Had some questions, and we're going to rambletron it on, so here it is. I built this thing circa 2013 or so the thing's like 7 years old or so at this point. And the whole impetus was to do some long duration, to build a battery pack, right? So that's what it's all about, building battery packs that you can tab weld onto to batteries, to the 18650 lithium ion cells. So that's what we're doing. It all started with this quadcopter here in the lower right. And I wanted a long duration flight battery. So I was checking out RC groups at the time. There's a guy named, a user named End of Days, and he was really into this long flight duration stuff and big, get big quadcopters with 17-inch props and big spans and just all battery, and get like 2 hours of flight time. And so they were just hovering their choppers for as long as they could. So this was I wanted to go that direction a little bit with this quadcopter, so I had it configured a little differently, little different motors, longer booms. It's a multi-wee copter with the Warthox board, so it's kind of old school. 10-inch props I had on it, so I built the battery there in the foreground, this pack. So that is a 4 parallel 2 series pack, so 8 volts. It's got the Panasonic NCR 18650B in it. So that's what I used to, that's the whole reason I built this tab welder, just because I didn't want to solder the cells because that heats the cells up and it can be detrimental to the cell. I also wanted to keep weight down. And to build this pack with these special cells, the Panasonic's, I believe the Model S, Tesla uses these, or at least they did. So they're humdingers, but yeah. So that's the whole point. Build a gizmo to weld battery packs. So that's it. So it was just the means to get the battery pack. So the fit and finish isn't good. It was just get it done, get it utilitarian, and get it used. Get it a usable welder so I could make a pack. So I didn't spend a lot of time on making it nice, just that it worked. So that's kind of how that all started out. Alright, so I've got you off tripod, just shooting at the screen here. So here's the link to the instructions that I use. So August 1, 2012, it's a Hackaday article. $100 capacitive discharge welder. And that's about what mine ended up costing. So this is it. It's by Brian Benchoff. There's the link, and it got a little virusy on me. So I'm not going to go any further on that. I thought I had a PDF of it saved somewhere in my project files. Nothing. So someone had asked for a circuit diagram. I don't have that either. And I was hoping to kind of get something with this, but so that's where I'm at with that. And to have me do to try and draw a circuit diagram would be kind of funny, hilarious actually. So anyway, so that's how it all started. So circa 2012, and that's what I used to do it. Alright, so despite not having a circuit diagram, we can go ahead and go through what's going on. You can still come away with something, right? So let's do that. So with these things, it's pretty much 3 main kind of things going on. You have a charging circuit, something to charge the capacitors. You have the capacitors, right? So they hold the energy, and then you have a switching situation just so that energy can dump all out at once through your electrodes into your tab on top of your cell to weld the cell. Alright, so first up is the charging situation. Kind of funny, but so yeah, I started with EC3 connectors. I'm into XT60 now, so I don't use those anymore, but that's what I had for this thing. So it goes into, it's kind of a Rube Goldberg kind of situation. If you're a proper engineer, it could even be, it's pretty silly really, but so it's going input into a booster. It's just a voltage booster module, right? And pretty easy, straightforward. That boosts it up to like 20 volts, okay? And for welding with my caps, and I'll get to the farads in a moment when I get to the charging section, or the capacitor section. With the energy I have, 16 volts is a good number to tab weld cells for me. So this is boosting anything, any input up to 20 volts. Then it goes into this buck converter that has a constant current. So it's voltage controlled and current controlled, right? So the buck converter drops it down to 16, or if I'm doing some like the wire that's the fusing wire for cell level fusing, I got into that with my big off-grid pack, but I use 13 volts for that. But anyway, so you can adjust your voltage that way, and then I think the current out is 5 amps or 6 amps, so it's not huge, huge amount of current, and it charges, I think it charges the caps in like 10 or 11 seconds or something like that. So it's definitely not built for using all day long, and I did try to go ahead and up the charging current with just an actual boost converter, a boost module that had current control, and then I fried that module, so we're stuck with the old way anyway. So that goes out through a diode into the switch, and the switch just goes out to the capacitor. The capacitor bank has a receiving EC3 connector, so on and so forth. And this switch is like a three-way switch. You got a high, that's on, and then a low, that's off. It came out of a hair dryer. So what happens is on the high you charge, off is off, that's center position. Low actually brings it back. Low actually will bleed. This is a big old power resistor. It is I think it's 2.7 ohm. I think 2.7 ohm power resistor. So when you put the switch in low, if you want to discharge the caps, right? So that's kind of important. Put in low, it'll discharge back to this power resistor. So it's got a ground connected to the negative connected to the caps, and then putting in low connects the positive of the caps to the power resistor. I'll show you that. We'll do a demo. So that just drops, pulls everything out of the caps. No fire, no sparks, no zaps, no noise. Nice and easy. So that's the kind of the charging situation. It's kind of the two modules. People have commented that that's kind of silly and ridiculous, but what it does, it gave me flexibility on the input voltage. So I could do like a 19 volt laptop input, laptop power supply, boost it up to 20 volts, and then bring it down to 16 with the buck. Or I could do a 12 volt power supply out of a computer, boost it up to 20, or anything. It's lots of configurable, lots of things you can do. I use it mainly, I use like a 4S lithium ion pack, so about 15 volts, 14 volts. That's kind of what I use mainly. But basically having that just gave me flexibility on the ins and the outs. And this is a tray from an old laptop battery, and just taped in there, and it's just stuff hanging out, so it's really not, fit and finish wasn't the goal here for sure. Alright, so let's move on to the caps. Alright, capacitor bank. So pretty much I have 16 of these. They are Nippon Chemicon 36DE, I'm just reading it off. 98 89,000 microfarad, I believe. 30 volts, so I can go up to 30 volts. I did actually try to go up to 30 volts, and I tried to tack weld, spot weld thin aluminum angle, and it kind of worked. They were really weak. It did kind of work, but then it got hot, and my solder joint to the silicon to the SCR, the silicon controlled rectifier, it got hot and came undone. So that's what happened there. So anyway, yeah, that plenty of power. So that would be 16 in parallel with this. So they had little screw terminals, and then I used it's 1/4 inch thick. I think it's 3/4 inch wide, 1/4 inch thick copper. I got from Granger. That's bus bar. I remember that being like $28 or something like that. The caps were, we'll go check a spreadsheet real quick and check out the what kind of energy we get and all that with these caps in parallel. The caps, those were, I remember sourcing them when it was hard. So you can get, the voltage range and the farads that you want at the time. This is 7 years ago, so at the time it was difficult. Like anything that worked was like $200 or $300 just for one cap. And if you can get away with one cap, I did start out with one cap. It was a 1 farad car audio. It had the juice, but in my system is probably more inefficiency than, and just didn't seem to have the power that I wanted. And so this is version 2.0 with the caps is kind of why I did that. But sourcing was the whole reason why I have 16 caps instead of 1 or 2. So sourcing and cost. I was trying to be cheap, and $100 I think is what I was shot for. So let's look at the spreadsheet quick. All right, here we go. So I've got you off tripod. Here's the spreadsheet I came up with. Yellow line was the Mark I capacitor, the car audio one. So it had 1 farad, and then at 16 volts was my welding voltage. Came out to 128 watt seconds, which was enough to do a little bit of welding, but for the power I needed a little bit more, I think. So the Mark II with the caps that you just saw, it ends up being 1.424 for capacitance. That's just pretty much 16. Show you this. So yeah, 16 times the 89,000 microfarads, and then just divide that by the million, I think, and then so that comes out to your 1.424 farads. I have a couple of voltage scenarios here, 18 and 30, and so the 18 is closer to 16, which is normal. 230 watt hours. So that, if you're around the 200 watt hours, that will get you in the ballpark. So again, that one's circled there, 1/2 capacitance times voltage squared. That gets you your watt seconds. So if you're around that 200, that should be good. All right, so here we are. Hopefully the fan noise isn't too bad. My lights have fans, and we're going to hopefully switch that out at some point. So yeah, here's the front of the caps. So you have, because they're parallel, you end up with 2 positives and 2 negatives terminals for the caps, right? For the capacitor bank. Here is the EC3 from the charging, right? So that goes in. There's a positive on the charging side, negative on the charging side, and then we have positive on the output side, the welding side, negative on the output side. So pretty straightforward there. On the positive side, okay, so now we're going to get into discharge, right? That was the capacitor bank. Now it's time for discharge. So there's the terminals, the electrodes, right? It's 6 gauge copper solid. So that's all simple and uninterrupted. So you have positive out to that electrode. All right, so on the negative side, I'll talk about the SCR, and then we'll get into the gate firing of the SCR, which is kind of probably the trickiest part about this whole business. So, and again, this is probably the part where I'm a little shortchanging you by not having a proper schematic. So, sorry about that. So here's the negative electrode tactile switch that's out of a router, like a Wi-Fi router. Okay. So that fires the gate, right? And we'll get to the gate firing in a moment. So here's the rectifier, the SCR, right? So it is a, there we go, better. So it's got the, like the screw bottom or whatever, and I couldn't find anything that would, the threads are really weird. I couldn't find anything that would tap into it. So I have this wire, solid wire going around it to this crimper guy. I think it's for lightning rods, lightning grounding rod kind of stuff. Anyway, from the hardware store. So yeah, initially I had this soldered, big old blob of solder, the heater, torch, and I was doing the 30 volt aluminum welding, and it got too hot and it came apart. And this is, I couldn't get it resoldered. It was a pain. So anyway, that's kind of a, you know, a pain in the neck. So anyway, so that's how we've managed that. Got the wire just pretty much, I think, pinched. I think it's 8-gauge wire. It's just pinched in there, so it's pretty, you know, loosey, kind of half-assed, whatever. So here's the SCR. Let me see if I can get that. Okay, there we go. So it is a 100 amp SCR. It was a cheap eBay one, about 14 bucks. And then, so it's in the low side, on the negative side, right? So the, there it is. So the anode is down at the bottom, cathode and the gate should be on top of that, which would be up into the caps. So pretty straightforward there. Alright, so now on the rectifier, you're looking at the gate. This is the gate. Goes right down into the top of the rectifier there. Alright, so here's the gate. I have it connected with this red wire. It's a jumble of wires, I know. It's really not too bad. So then that comes all the way down to the tactile switch I showed you. The trigger switch, right? So there's your red wire. Black wire of the switch comes back to our gate firing battery, right? That's going to be this one. So this battery runs the gate firing of the SCR, as well as this voltage meter. So that's it. That it powers that and the gate. Okay, now the black wire that connects. So ultimately, this black wire goes into the gate. This positive from this battery bank, right? This small one. In between that is a 47 ohm resistor. So at 4 volts, that should be about 85 milliamps. So it doesn't need a lot of current to fire that gate. A lot of people have asked me about what kind of resistor I was using, and the color coding is a little weird on that one, but it's 47 ohm, I measured it. It comes out to 85 milliamps to fire the gate, and that kind of jives, I think. So now we need to look at how this is hooked up, this battery, pretty much. Alright, so now we know that the gate of the SCR is hooked up to the positive of this battery bank. It's just a 4 volt, it's 2 in parallel, 18650, okay? So and I don't even have it protected. I even have a little protection circuit board that I could hook up to it. I just haven't done it. And so what I use to charge it, I have a little board with magnets on the wire out to magnets, or hooked up to magnets, and that's how I charge this thing. I don't need to charge it that much, but that's how I do it. So here's the negative side, right? Negative side of these cells. It just goes. So we've got two. Well, you can't even see that. So I have two black wires coming off of the negative of our 4-volt battery, right? So the one is going up to the voltage meter, okay? And this switch just turns the voltage meter on and off, and it's just taped up there because I don't care. And then the other wire is grounded to our ground on the cap bank, okay? So that's how you get your common ground. So when you fire your gate with this, the ground is common here, so that's how you can get the gate to fire, okay? Otherwise you're not going to get it to fire. What else? And then this thing is, this meter is a 3-wire voltage meter. So the meter, because you didn't want the meter needs to be a 3-wire, because you don't want to draw the caps down powering your voltage meter, even though it's like 10 milliamps or something like that. You can see it draw it down. So that's what I ran into. So so pretty much this is powered by this pack and not the caps, and then you have the sensor wires going to the caps. So the yellow or the white is going to be the sensor wire for the positive, and then it has a black that's hooked up to basically ground on the caps, but it's hooked up to the battery pack negative, as well as the negative on the caps, and then the positive on the battery goes up and powers the switch, powers the voltage meter. So that's pretty much it. We'll charge it and maybe do a weld or something, huh? All right, here we go from the top. So here's my 4S power bank. I think there's 94 cells, 96, something like that. And this is kind of partly why I built those before. There's 4 of them that it's beyond the scope of this video, but this is before I had a tab welder, so it's another reason why a tab welder helps, because it was ridiculous. I used cell holders, and I built little terminals, and it was ridiculous. So that's why this tab welder is handy. So I need to redo this. It's just not as not lower on the totem pole, right? So okay, so we got the EC3 input connected. There's our charging switch, and it is so we got red lights on the modules. Cool. And then we are in, here's a close-up of the switch. So it's in the middle, high, low. High is charge, low is discharge. Okay, and then here we go, pan back out, and then so that charges the caps. That charges the caps. So let's go ahead and push it forward. We've got 0 volts, right? And then we'll go over here, and we'll just we'll put a tab on this grody old cell I have. The lighting is just not very good. I need to work that out. Anyway, and it's loud. Okay, I'm gonna push it forward. I'm looking through the camera. Here we go. So that's your charging speed. 7, 9, 8, 12 volts, 13. Oh, so I had this set for fuse wire, 13 volts. So I need to up it. And I will do that with down here. The V on the left, the pot, I'll just turn that until I get to 16. Alright, so we have 16. I'll show you a discharge here. So I'll just click the switch. So it pulls it out nice and safe. Okay. Okay. We'll go center. Now I want you to watch. The blue light is current limiting, so I'm going to flip it to high and charge it. Blue light, current limiting. 10 volts. Current limiting. Off. 16. So it's pretty, it's kind of slick for having cobbled together stuff. Alright, back to the tripod. So there we go. Just a quick little weld there. So yeah, that's about it for this one. Sorry I don't have a proper schematic, but I think hopefully that helps. And then you know, just pop me any questions you have. Thanks. Oh hey, so I forgot. I wanted to close it out with what you could probably do now. I mean, I built that thing 7 years ago. So I know on this is banggood.com. So I know they have options for you. So looks like there's like a $17, you know, this gizmo. I'm not sure if you need other stuff. Probably a battery as well, or you know, a big battery pack, something like that. A 12 volt to weld with that. Here's a much more expensive one, but it has like the little. They're held together, and mine are you know, separate. The electrodes, and it'll tell you when you're doing a lot of welds, and mine isn't built for a lot of welds, but it's the repetitive strain situation. It'd be nice to have them set up like that. And check out this HB Powerwall guy. He's got something called the K-Weld, something like that. He builds big off-grid storage stuff. So anyway, that's something to look at now. This wasn't available, this kind of things. I don't recall any of this, you know, available when I was doing this stuff. So that's probably what I would do, you know. So there's his. He's got the, you can kind of see that triangle guy, that's the electrode holder. So you just hold the triangle down onto your cells and you're ready to rock. That looks so sweet. Look how much smaller it is than mine. Way less space. So anyway, yeah, so there's that. I wanted to end it like that. So thanks for watching. You guys have a good time. Have a good day, man.